Good morning. I wanted to give a quick tutorial about how to go from condensed structures to line structures. There was a specific mistake that kept happening over and over, so I wanted to make sure I gave some clarifying information. First, I actually want to start at this problem that I wrote down here at the bottom. So if I have this structure, there's a total of 1, 2, 3, 4, 5. Oh, but there's 2 of these that are in parentheses here, carbon. So I actually have 2 carbons times 2, so I have 4 carbons, 6, so 4, 5, 6, 7 total carbons that I have. I like to count my carbons so I can double check my answer at the end to make sure I have the right number of carbons at least. And whether you're going to line structure or Lewis structure, it doesn't matter on how you're going to do this. I'm going to show you both here. As I'm setting up this structure, most people would start here and say, well, I have a carbon that has 2 H's that is double bonded to a carbon with 1 H on it and another carbon with 1 H on it. And this is where it got tricky. Many of you had no problem if it was just a CH3 that was in this group, but there were few errors when there was a CH2, CH3. So this purple parentheses that I have, there's 2 of that whole group on this carbon. It's connected to that carbon. So I have on this carbon, this one is the same as this one, I have a CH2, CH3 connected there. And another, because there's 2, I actually have 2 of them going that way, another CH2, CH3. So what does this look like in a stick form? It looks like this. I have a double bond, and I have this is this carbon and that carbon, one other carbon, and off of that carbon I have 2 ethyl groups. Ethyl is the name of a 2 carbon group, and so that's what that structure would look like. Okay. We talked about positives and negatives of different structures. I want to point out, compared to Lewis structures, line structures take much less space, so I can draw them much smaller. So that's that way. I want to do a couple more examples. These are examples directly from your homework. Same idea here, but because I start with something here that has multiple groups off of it, I'm actually going to start my structure off of the first carbon that doesn't part of that group. So I'm going to start with this carbon. So I have a carbon. On that carbon, I have an OH. And then I also have 3 times I have this group on it. So I have this carbon connected to this one once, twice, 3 times. So I have off of this a CH2, CH3, another CH2, CH3, and another CH2, CH3. Notice the order that I'm putting these in. If I have a carbon, the H's are connected to that carbon, and this carbon is connected to that carbon. I've used a mixture of condensed and Lewis structure in this particular drawing, which is what you'll see frequently. The line structure for this would then be, I have my OH. It's connected to a carbon, which is that piece, that end. I'm going to add to that end 3 different groups that are off there. So that's one way to draw the line structure for that compound. And that the problem many people had was they were trying to do this, but just add the CH3 connected to that carbon, not the carbon that was next to it. So they were confused that these 2 pieces were together in there. So let me think of another way to talk about that. It's really like I have these pieces, I have this 3 times, right? The wiggle would be where it needs to connect to something else, and all 3 of those need to connect to this piece. It's like distributive property in math, actually. Let me give one more example here. So here I have this problem, and again, because this has multiple pieces coming off of it, right? This is duplicated. I'm not going to start drawing the structure here. To me, that's easier to actually start here. So I have a carbon with, I really should have had a 2 there. I made up that problem. I didn't make it up well enough. Did I even do that? Yeah. A carbon here with a CH2OH off of it. That carbon also has an H, and it has a CH2 connected to a CH3 as I'm told here, this carbon is connected to a CH2 connected to a CH3. You can see how I can follow a condensed structure both left to right or right to left. And this carbon here also has another, because the 2 there, another CH2 connected to a CH3. And so my line structure there would be, would look like that for that structure. I hope that helped clarifies a little bit, and we'll talk to you tomorrow morning. Have your homework done.